Hello children, welcome to channel Sube. Children, I changed the question so that it is going to be a target question now. So here is your target question now. Start it. I did some changes in the question. A ball is projected at a velocity of 10 meter per second horizontally from the top edge of a building of height 20 meter. While falling, the ball splits into. So read the question. Pause the video. Pause the video and honestly try to solve it. So as you have paused the video, now I am going to start. So let us get a copy. So as previously, let us find out the time first. This time for the first piece we calculate downwards. This is the topic. Downwards u equals 0 because the velocity, initial velocity is horizontal. There is no angle, totally horizontal. Therefore no component downwards. So acceleration downwards how much? 10 due to gravity. Displacement vertically how much? 20. It is given. T is what we need. It is a scalar. We can't draw arrows. It is not a vector. So downwards, what is the equation we can use? S downwards equals ut plus half at squared. So let us substitute the values. 20. U is 0, therefore this whole totally this term goes to 0, therefore we don't have to write it. Half times 10 t squared. So as previously we get the same answer, t is 2 seconds. Because these distances are same, therefore gravity also same, therefore we get the same answer. Now we have to find out the initial velocity of this first piece, which is x. Initial velocity of x, this piece. Half piece, not half. Mass is given as 1:3 ratio. So let us use the equation S equals ut horizontally. The topic is horizontal. So as we know 10, u, let us suppose as x initial velocity. So here u is now x, time we know 2, so x is 10 divided by 2 is 5 as previous meter per second. So that is the initial velocity of this half. So initial velocity of this half is, as soon as it got splitted, the initial velocity is to this way 5, not 10. So downwards it is 0. So now let us use conservation of linear momentum theorem. This one, this half, not actually half, quarter, it is like this, it should be like this, not exactly, it's something like this. Why? The ratio is 1 to 3. So if this one is m, this one is m divided by 4, this one is 3/4 m, 3/4 m. So the initial velocity of this one is 10. So this diagram should be corrected like this, because only this part takes P6. P6 means that one also quarter, not half, quarter. Like this, this one is three-quarters. So the conservation of linear momentum theorem. Velocity 10. 10 is to the whole ball, not segments. Now this diagram is valid only after splitting, because that is why we took this as quarter and this one 3/4 after splitting. After splitting, the velocity, horizontal velocity is x, time doesn't change, but before we can take 10 as velocity, horizontal velocity, if we consider the full ball before splitting. So So now this one is before splitting, huh? This one before splitting. That is why we have drawn this diagram before the arrow. After the arrow is after splitting. This one after splitting. This one before. Then what we do, we take the multiplication of m times v. M times v equals m times, what is the velocity of this one? We have found here this quarter. Velocity of this quarter is 5. That is what all the way we found, taking as x initially. Right, now the velocity is 5. Velocity of this one we don't know, say y. Then 5 times mass mv multiplication plus, because the same direction, y times 4/3 of m. So m cancel, here 10, 5 divided by 4 plus 3y divided by 4. Then we take this one to the left, then minus 5 divided by 4 equals 3y divided by 4. Then take 4 as the common denominator, then 1 times 4, 4, then 4 times 10, 40, minus 1 times 5, 5. Then 4 cancel, 35 divided by 3 equals y. So that is the velocity of this piece B. This one piece, no, what did they say, x and y, x and y. So y, this one is capital Y, this one is capital X. So now we know the velocity this way. So velocity of y. Now we know the velocity of y, initial velocity. So let us now calculate the projectile. So now we are considering this y, piece y. So it is 3/4. So initial velocity of that is, now we know y is how much, 35 divided by 3. So now let us calculate the final this value, that means horizontal displacement. So we get the diagram like this. Like this. time is same because this distance is the same, it is the same, so time is 2 seconds. The time changes only if this height changes, otherwise it doesn't change. So therefore we can calculate to this side, this direction. Only we have to use s equals ut. S is now r, u is 35 divided by 3, the time is 2. So 70 divided by 3 is the answer. This is the horizontal displacement of y. So the answer is first one. This one is the answer. Now I am going to, so children, now I am going to show you the other method, that is the method center of gravity, using the center of gravity. Using the center of gravity. So these spaces after splitting are like this. This one is only quarter of mass, this one 3/4. So the center of gravity, where is it? If I asked the center of gravity of this system, total thing, after splitting, where it would be? This one mass is m/4, 3/4. This one 1/4, 3/4, because 1 to 3 ratio. So the force downwards, mg divided by 4, 3 mg divided by 4 is the force downwards. Force downwards. So where it would be the center of gravity of this system? Here, or somewhere. First of all, what you have to do, connect these two pieces by using a massless stick or a rod, massless. So the distance, so we take that ratio, given ratio, it is easier, 1 to 3. So altogether four heaps. So we have to divide this into, therefore 4, this distance, divide by 2, again divide by 2, now 4 parts. So you have to take this one, since since the value of this left side force is 1, so length you have to take from this right side, not from this side, since this one is here. You have to take the length from this side, one piece. So here is the center of gravity. Here is the center of gravity. Or if you use this 3, the force 3, you have to take the length from this side, 3 parts, 1, 2, 3. So again here is the center of gravity. So like that easily you can find out the center of gravity. So this one is the center of gravity. So now we are going to calculate the motion the displacement of the center of gravity, because we can use that 10 given 10 directly for the center of gravity. If you calculate for center of gravity, we can use it directly. So center of gravity is here now. So remember 1, 2, 3, 4. At the last part, last piece here, center of gravity is here somewhere, very close to this one. So 1, 2, 3, 4 times. Understood? So this distance you have to divide into 4. Again like this. So center of gravity is here now. So the path of this center of gravity is now like this. The motion is like this. So now we calculate for the center of gravity. We calculate the motion of the center of gravity. Let us keep it here. The time is still t, because this distance is the same, therefore the time doesn't change. So time is still 2 seconds. Now we calculate to this side. So we are going to find out this distance to the center of gravity. The distance from here, bottom of the building, say r dash. So S equals ut. S is r dash. U is, then now you can use this directly 10. 10 times 2, 20. Time is 2. 20 meter. Now you have to use your common knowledge. I am going to use this bigger diagram, because then you can see easily. So this distance from this bottom of the building is now how much to this level? How much? Let us use black color to this place. How much is it? That is what we found. R dash is this one to the center of gravity, or this one is center of gravity, R dash 20, 20 meter. So now this 10 to here 10 meter. It is given here, this one to x. This one is x, isn't it? This one is y. To x, the distance from the bottom of the building is 10 meter. So what is this distance? 20 minus 10, 20 to here, 10 to here, then 20 minus 10 is 10. 3 parts, 3 pieces of this. Previously we have drawn this length, distance, this line. So 1, 2, 3. These 3 pieces equal to 10 meter. Then how much is 1? 10 divided by 3. What about this one? This one, that also same, 10 divided by 3. What we have to find out? We have to find out this distance. that is where the piece Y striking the ground. So this distance is what we need, this distance. So these ratios now we don't want, these masses also we don't, forces also we don't want. We need this R, this one is the R, final answer. So let us find out 20 plus 10 by 3. 20 plus 10 by 3, that is the answer, R. 20, this is small piece we have now found from here, from this part is 10 divided by 3, because altogether these three parts, the distance of these three parts, the length of these three parts is 10 meter, and one piece is 10 divided by 3. So here is also a one part, this one also a one part, whatever these parts are equal. So 20 plus, how to get common denominator 3, then 60 plus 10, 70 divided by 3, the same answer, same answer we received, this one. And there's another method, again a sub method of this one, without doing this thing, we can, after finding this 20, we can go to this way or this way, but it is rather difficult, but that also is a method. So this the building, this one is the building, so this one is the ground. So we know this piece, this quarter piece has fallen here 10 meter away. So the distance is 10 meter. This distance is 10 meter. What is the force downwards? Force downwards is mg divided by 4, because the mass is quarter. M divided by 4 times g. Then what is the, then again we are drawing another diagram for y. I don't draw all these things in the same diagram, because then it will be complicated, you will not understand. So this 3/4 is fallen how long away? R, that is what we have to find out. We don't know that. That is called R, capital R, the distance. Then there's another diagram for the center of gravity. Since this one is here, this place now we are drawing, this red one, this one, center of gravity, we are going to draw it. It is in between these two, so therefore we have to draw it somewhere here. Center of gravity G. So the distance, so I delete this one, this one we don't want. to the center of gravity, what is the distance? 20, r dash we have found as r dash is 20. Here we have taken it as r dash. We have calculated here r dash equals 20. 20. The distance to this point is from here 20. That is what we have found. We calculated for center of gravity. Here r dash is that, here r dash, this distance r dash. So we take it to this diagram, 20. 20. So the force downwards is, the G is the center of gravity of this ball, not quarter, not 3/4, totally this ball, the center of gravity. It is splitted while falling down, it doesn't matter. So that is the center of gravity of either of the total ball or either of these two pieces. Then the mass of this one is m, because quarter plus 3/4, quarter plus 3/4 is 1 m. mg is the force. Here mg is the force. Here mg divided by 4. Here mg divided 3 times. It is deleted. Yeah. 3 times mg divided by 4, because we have taken it as r. That is, this r is what we have to find out. This is the perpendicular direction distance. So now we get the momentum. So this center of gravity, the momentum given by the center of gravity, momentum at the center of gravity is equals to these two, sum of these two. So mg times 20 is the momentum. Now we are taking momentum. M over momentum. We are taking the momentum. 20 times mg equals the momentums of these two. That means the momentum of the center of gravity is equal to this 2. So that is what previously when we did. Here you can see, here this one is the momentum of the ball or the center of gravity. This is the momentum of other two parts, the sum of other two parts. So we are taking the same thing in a different way. So this one is the momentum of the ball, that is the center of gravity. This is the quarter, so the momentum of that is mg divided by 4 times 10 plus, because all are to clockwise direction like this, around the bottom of this building point, this point, bottom of the building, around that we take the momentum, so clockwise. So this one 3 mg divided by 4, understood? This one is before splitting, before split. This one after, this one also after. So momentum should be conserved, therefore we can write before splitting the momentum must be equal to the momentums after splitting. So simplify, mg cancel, 20 equals 10 divided by 4 plus 3, but 3 here the distance r, this one r times r, 3 by 4 mg times r. This r is what we have to find out here. This r means what they ask is this distance they ask to the y, distance to the y. So that is what we have taken here. This one is y. You can see 3/4 are there. I have drawn here, 3/4 are there. So this distance is what they want, r. So it is here in this equation, r. So mg cancel, only r here. R. So 20 minus 10 by 4 equals, we take this one to this way, here the equation equal sign, 3r divided by 4. Now take 4, 1 times 4 times 20, 80 minus 10, then 4 cancel, 70, 80 minus 10 is 70, divided by 3 is r. Same answer, but the path is longer. If you see that this one is easier, dividing pieces like this, the distance to the center of gravity and finding the center of gravity exactly, then I think it is easier. Somehow there are two methods like that. So this one is the another method. I said it is the other method. But first of all you have to find out this distance 20 of the displacement of the center of gravity. But we have to find out not the displacement of the center of gravity, of the y, displacement of y we have to find out. So however, now I showed you various methods. Children, I think you are happy, you must be happy. So if you are happy, you have to make me happy too by subscribing my channel if you haven't done it yet, and also share my link among your friends so that my audience increase. Then press the bell icon also, and press the thumb up icon so that I get likes. Then my video will be pushed by the YouTube automatically. So children, thank you very much for watching my videos, and thank you very much for subscribing my channel. Then see you tomorrow at 6 o'clock in the evening. So long, goodbye.